Welcome to our EC311 final project video. For our final project, our group decided to create the classic game Whack-A-Mole for the FPGA. Our code can be split up into three main sections. We have user input decoding, which takes information from the user via the switches and buttons on the FPGA and converts it to useful information for our next section. Game control uses the information from the user and creates the game state via modules such as mole picker, score tracker, and timer. That information is then sent on to our last section, output decoding. Here, we translate that information for the 7-segment display, LEDs, and the VGA display. So here we have our top module for Whack-A-Mole. Down below, you can see we have our module that takes the button inputs from the user. We have our switch inputs for the hammers to hit the moles down. And then we also have our countdown timer here. Followed by that, we have our edge trigger count. This is the signal that sends to the mole picker that a new mole is required. Our mole picker here goes ahead and selects a location for the mole to pop up. Down below here, we have our score tracker. And then all that information, so we have the time gets sent to here. So we decode the time for the 7-segment display. We have the score sent to here. That's also decoded for the 7-segment display. The difficulty is also displayed on the 7-segment. And then finally, we have our 7-segment decoder here that will take all the information from the previous 3 modules and decide what needs to be outputted onto the 7-segment display. And then down below here, if a VGA cord is connected, the game can also be played via a VGA display.
So I'm going to be talking about the module that essentially controls the mole's behavior, called mole picker. What mole picker does is mole picker takes in the internal clock along with an enable signal, the difficulty, and the input that is sent from the scoring module that tells us which mole has been hit, and it outputs the current state of all 8 possible moles. So how it does so is it uses 2 linear feedback shift registers to generate a random number in 3-bit encoding from 0 to 7 that will correspond to a random mole and a random duration of time with which the mole will stay up, called rand mole and rand time. We use rand mole to determine which mole should be popping up. So if the number that our LFSR is outputting is 100, that means we should be popping up the 5th mole. So all of this is fed into a module called mole control. And this mole control takes in the random mole position along with the random time, and it makes it so that when enable is on, it will output this new set of moles. And it will push the mole down by itself if the user hasn't interacted with it in time. So mole control over here uses something called mole timer. And what mole timer does is it takes in each bit of this input signal that we're getting from rand mole, along with the enable signal and the difficulty, and it outputs the current state of that mole.
Hello, this is Chen Liang. So I'm here. So first I'm going to introduce the difficulty system of our project. We basically have 3 difficulties. 00 represents easy, 01 means medium, and 10 means difficult. As you can see, the difficulty determines the time window between 2 moles pop up. And as you can see here, the easy mode, the time interval is the largest. And as the difficulty increases, our time window decreases. So for every positive edge of our clock signal, the current count will increment by 1. So this number, the larger this number is, the larger our mole will stay. This is how we track the score. In this module, we have 3 variables, which is the C mole, the current position generated by the system, the score, which is the user's current score, and the mole hit, the position that the user decided to hit. So if the game has started and the game is ended, we will reset everything. And if the game has started but yet to end, we will start this enable signal if this enable signal will tell the system to generate a random number, and this random number will be put into the CMOL variable. And then we will use one hot encoding to check if the user's input matches with the mole's position. So as you can see here, if the one position of the switch, which is the user's input, matches with the one position of the current mole, then we will increment the score by 1 and then set the current position, the current mole position to be 0, which keeps it from displaying. And then this mole hit, we will generate the mole hit accordingly through the switch, which is the user input.
Here we have the module that's responsible for producing the canvas of the VGA. So in our case, it's 640 pixels by 480. We take some inputs of the clock, a pixel strobe input, and a reset button, and we produce a horizontal and vertical sync along with a current X and Y position. Here we have some local parameters that we use in our code, followed by these two registers. H count represents the line progression, and V count represents the starting position of the line on the screen. So we have some assigned statements for the horizontal and vertical sync, along with the X and Y coordinates. Inside of this always block here is how the canvas is made. So we have a reset case that sets our H count and V count back to 0, so the line progression and starting point back to 0. And then if the pixel strobe turns on, i.e. a pixel is to be turned on, then we do a check. If the line progression has reached its maximum, we set it back to 0 and we shift its screen position over 1. Else, if it hasn't met that maximum, then we go ahead and we increment that line progression by 1. And then we always check to see if V count has equaled the maximum length of the screen. And in that event, then we set V count back to 0 and we start all over again.
So for our top square module, we take the input of a clock and a reset button, but we also take an 8-bit input for a random number. So this random number symbolizes a random position that we generate to symbolize where the mole is popping up, and an 8-bit number to indicate the mole hit, where it basically just tells us if the user was able to hit the mole that popped up or not. And then we have outputs for to display on the VGA. So we had the VGA horizontal component and the VGA vertical component, as well as the VGA red, green, and blue, even though we only use the VGA red and green in our case. And so the way we made the grid was we first made one large red square that encompasses the area of all of the grid. And what we did then was we subtracted area from that red square in order to sort of chip away and create an 8 individual squares out of this initial large square. And so that's what you can see is being done from squares 2 to squares 9, and then in the assigned statement at the bottom. Now, the way we symbolize that a mole is in a specific square is we overlapped a green square over all the 8 squares are the initial red squares. So these green squares, squares 10 through square 17, are all overlapped over each red square. And whenever we want to symbolize that a mole is in a certain position, we just activate that green square to create a yellow square in a specific position. And similarly, the hit squares we use to symbolize whether a user was successful in hitting us in the mole. And we use this to overlap over the red squares to take away that red square and just leave the green square to symbolize that a mole was hit in a certain position. And so here you can see how we were able to sort of set up the grid. You can see in the grid, we're subtracting area from the large square minus, and also the mid square. So it's only 8 squares. And this is how we were set up the initial grid. And so how this case statement begins is we initially assign green as 0, and then we construct a grid. And now based on whether, based on the position of the random number, as well as if the user hit the mole or not, what we do is we assign the green square to wherever the mole was at that position, depending on the random number. And we subtract the red square that was there from, we take a red square and subtract that from the red square that was there. So we're only left with the green square, so that it would only seem to the user that a green square is there, signifying that they hit the mole. And so we use this logic and we carry it through the entire case statement to signify all the different positions that the mole could have been in and that user could have hit, to show that when there's a mole, it's going to turn yellow, and if the user hits it, it's going to turn green. That logic basically carries through all the 8 positions, and that's how we're able to construct the game on the VGA display.
So this is our EC311 final project, Whack-A-Mole. And I'm going to start the demo off by showing how you can initialize the game by setting the time and the difficulty with which the game will be played. So right now the user can set the time or set the difficulty and swap between the two using the left and right buttons. Using the upper and lower buttons will increment the time with which you can play the game and increment the difficulty up to a maximum of 2. And pressing the middle button will start the game. So as you can see on the difficulty of 2, you have 3 moles right off the bat, and they're changing really fast, like less than a second between each new mole popping up or popping down. And then if you decrease the difficulty by a little bit to 1, you still have like a little bit of moles, but now as you can see, there's more time between each mole popping up and each mole popping down. So the user has more time to react. And then on the lowest difficulty, you start off with 2, and as you can see, you have like 2, maybe 2.5 seconds to respond to the mole before it actually changes. So clearly we're able to control the difficulty, and as you can see in all 3 difficulties, when the timer ran out, the game immediately stopped.
So this video shows the easy mode. The mole disappears as I hit the corresponding switch. This is the medium mode, and there are chances that 2 moles popping up. The interval is a lot shorter. This is the hardest mode, and there are 3 moles popping up. The time interval is the shortest.
So now I'm just going to run through a quick 35-second gameplay and just show how our Whack-A-Mole is working. So as you can see right now, we just have some moles popping up, and there's really no rhyme or reason to how they pop up. And without me touching anything, they're popping down by themselves. And the moment that I hit a switch up or down on a mole that's popped up, the score will increment by 1, and it doesn't matter what the initial position of the switch was. If it was high and I hit it down low, it increments the score. If it's low and I hit it high, increments the score. And we can just keep playing, keep hitting the switches. Just missed that one by like probably a microsecond or something. And then as soon as the game is over, all the moles go down and the time flashes and your score flashes. So now I will be displaying the fact that the LEDs, the switches, and the VGA are all connected. So on the VGA itself, the squares are numbered from 0, 1, 2, 3, 4, 5, 6, and 7. And these squares correspond to the LEDs from 0 to 7 and the switches from 0 to 7 on our board. So as you can see right now, the second LED was on and the second square was on. The 7th LED, 7th square. Second again, 2nd square. And as you can see, there's a clear correlation between which LED is on and which square is being lit up according to how I numbered the squares. So now I am going to be displaying the fact that hitting a switch which has the lit up LED will correspond in the square turning green on our display. So right now I'm waiting for the first square to light up, and once it does so, I will hit the switch and you'll see that the square turns green. I guess seconds. Oh boy. Oh, there we go. You see? And as you can see, as I hit the switch corresponding to the LED that's lit up, the display goes green.